This video is part of a plan reading series, specifically the electrical detail and how to read a planned electrical detail. I'll explain how to read an electrical plan detail and also tips on how to help you pass your inspection and avoid red tags. And as I've talked about in other videos throughout this series, you always want to start with the cover sheet. And on the cover sheet, you want to go to the sheet index, and that's where we'll find the sheet we need to go to define the electrical detail on this plan set. So if you look at the sheet index I have up here on this slide, you see that E1.0 is the basement first floor electrical detail, and then E11 would be the second floor electrical detail. So those are the sheets we'll be concentrating on. And again, as we discussed in the bottom right corner of the sheet that you go to, you'll see E1.0. You have the architectural information, his stamp, his seal, and his signature, and some other information that I have blurred out on this plan set just for privacy. And as we start looking at this sheet, you're going to see things that obviously on the official block, the title of this sheet is going to be basement first floor, as we discussed. You're going to see symbols like GFCI, S3, S1, S4. We'll talk about those symbols as far as the switches go. These are symbols that are very familiar to electricians, but for a DIYer possibly, or a homeowner that's just trying to learn how to read this particular plan set or how to read the electrical detail, this might be somewhat confusing. There's often a legend on the plan set that tells you what each of these are. On this particular plan set, there isn't a legend. So this is something that's more of an industry standard. It's something that you could easily search out on a Google search to determine what these symbols mean. But we'll go over them so that you understand what they mean. On this plan set, in the slide that I have up now, you'll see that the architect provided an electrical power panel schedule. And I'll tell you what this is and what it isn't. So starting from the bottom up on the electrical power panel schedule, what the architect has given us is he tells you in his notes with note number 1, MIDI breakers are allowed. So those would be the tandem type breakers. So whether the panel accepts them or not, this architect is calling out in his detail that they are not allowed. He talks about balancing of the panel within 10% of A and B phase. Actually, he shows A and C phase. There's a couple typos here. The numbers don't add up if you were to add up the numbers. And then also A and C phase is not typically what you're going to see in a residential panel. So you'd see A and B phase. But what he's saying is within phases, they have to be within 10% of each other. So it gives you a suggestion of maybe how you could balance a panel out. And then if you go on the other side of the bottom, number 5, he says that the panel has to be marked, which is an NEC requirement. So all the breakers have to be identified. And then in the bathroom, number 6, he talks about there being a separate 20 amp circuit for the receptacle. So the lighting he wants on a 15 amp circuit, which is generally a good practice. And you can look in the NEC for the requirements. So if you had a 20 amp circuit, you would be able to use that 20 amp receptacle circuit in more than one bathroom if all that's on it is the receptacles. The NEC does allow that. What the architect is calling out is actually a good practice. He's asking for a 20 amp receptacle in the bathrooms, and then the lighting would be off another load. And then as you go up on the left side of the panel, you see that he's got everything labeled from the family room down to the smoke detector. And then also he shows you that he's built in some spares. He does give you an A and C phase wattage calculation and shows you how you can come to the amp load on this particular panel just based on those. But things are missing off of this schedule, like the laundry and other items. So this would not be a load calc. An actual load calc would have had to have been done by the electrician, but this just helps you maybe organize your panel a little bit better. On the slide I have up here now, it just gives you the 2 NEC methods for load calculations, the standard method or the optional method. And I give you the sections here. So again, that would have to be something that was calculated in order to have a proper load calc on this particular residence. So as I bring up the basement detail, you can see that there's going to be symbols that you're going to have to know. Again, most electricians are going to know these symbols, but if you're looking at it from a DIYer standpoint or homeowners trying to understand it, we'll go over those symbols. So you have the lighting fixtures, that would be what this symbol is. Then you have the arc that shows that those fixtures are connected together, so they're going to go on together. So if you look at the top left, you have the 200 amp underground panel that's being called out, so they're telling you it's an underground service, and then they show you approximately where the panel is going to go. They also show you in this detail that you have a 15 amp dedicated receptacle for the sump, and it looks like you have the same thing over on the other side for the ejector pump. You see by the stairs over here, they have an S with a line through it. So those are typically a single pole switch. So they're showing you're going to have a single pole switch turning a light on in the sump or the mechanical area. And then you're also going to have a single pole switch that turns the basement lights on. In this next slide, I'm bringing up a detail excerpt of the kitchen area. And again, you're going to see symbols on there that you're going to need to know. As I mentioned, this plan did not have a symbol legend or a key. So these are some symbols you have to look into if you're not familiar with them. But if you go into the kitchen area here, the round circle with the R is a recessed light or a can light. Again, you're going to see S's with slashes through them. An S with a 3, it's a 3-way switch that can control a fixture from 2 places in the room. You're going to see in the kitchen counter area that they have appliance circuits marked out. So they show 20 amp GFCI circuits along the counter area. You see that the dishwasher, they have a separate circuit they're calling out for the dishwasher. They also show a separate circuit for the micro. And then they show also different lighting fixtures. As we move over on the slide here, you get into the dinette and the family room. And again, you're going to see the same thing. So the switches, you're seeing a bunch of 3-ways down at the lower part of this slide. And those are switches that are going to control the light from 2 places in the room. You see that you have the recessed can lighting in the family room. You also have receptacles along the wall. If you go to the top of the slide here, you see that you have weatherproof receptacles outside. You also see that you have lighting fixtures outside. And then you have a single pole switch that controls those. And then finally, you have an excerpt of the second floor. It's a typical bedroom electrical layout. You see the receptacles around the room and the wall. You see the fixture outlet. You see switches on the wall, single pole switches, and one of them is controlling half of an outlet. So that's what this means here. It means that it's controlling half the outlet. So if somebody wanted to have a lamp there, you could switch the lamp on with that single pole switch. Then also you have a single pole switch going to a bedroom ceiling fixture. And then in the hallway, you see that you have some receptacles out there and lighting in the hallway. And you also have a 3-way switch in the hallway, so it's being controlled from another position in the hallway, which is typical. And then in the upstairs bath area, you see that you have a single pole switch that's going to a fan and a single pole switch that's going to a bath fixture. So all of these are pretty typical to an electrician in a residential build. Now, regardless of how the architect lays this out, regardless of where he puts receptacles and lighting, it has to meet the NEC. So 21070 of the NEC is going to have to be followed, as well as 210.8, 210.12. So 210.8 for GFCI location and requirements, 210.12 for arc faults, locations and requirements. So regardless of whether or not the architect misses it on the plan, you're still going to have to meet the requirements of the NEC. This would include any lighting outlets outside of entrances, lighting outlets in garages, detached and attached garages. So the architect may have missed a receptacle, but you still have to follow the requirements of the NEC for spacing of receptacles. On the cover sheet, it also indicates the codes that this plan was permitted under. So if you look at the electrical code, it was the 2008 National Electric Code, which could be a benefit to the contractor that's building this particular build, because the codes have changed quite a bit since 2008. So there could be some cost savings there, but you always want to check with your local authority having jurisdiction, the local AHJ, to make sure that it's still meeting the requirements of the authority having jurisdiction. If you want a more in-depth look of how to read an electrical plan detail, you can go to my website, buildingcodegeek.com, where I give you a full breakdown with tips on how to pass your inspection. And I'll leave a link in the description for that blog post. If you need help passing the AFCI, GFCI portion of your building inspection, I created a guide that I'll also leave a link for that guide in the description. It's a quick guide that'll help you avoid the red tags and point you exactly to where you need AFCI protection, where you need GFCI protection. I hope this video will help you read your next electrical detail on a plan set. If you liked the video, give me a thumbs up and remember to subscribe, and thanks for watching.